Guys, welcome to my channel once again. And if you are new here, this is Queen Favors TV. And if you have not subscribed to my channel, please click on the subscribe button, do like and share my video. Today's subject is electric, and we'll be calculating total resistance today. So stay tuned guys, I will be right back. So guys, before we dive into calculation for today, I want us to recap what we discussed in my previous video. I talked about resistance, and I said is the opposition that a substance offers to the flow of current. I want you to note this, that resistance is directly proportional to length and inversely proportional to area. There are three types of connection. We have the series connection, we have the parallel connection, and we have the combination of these two, which is series and parallel connection. Let's now define Ohm's law. Ohm's law states that the current that flows through a conductor or between 2 points is directly proportional between the potential difference across the 2 points and inversely proportional to resistance. Now, let's now go and do our calculation for today. Follow me, guys. So let's start by solving one exercise. So we're going to solve series connection, parallel connection, then series and parallel connection together. So let's start with series connection. Assuming we're given to calculate, let's say calculate the two resistance R1, which is 4, and R2, let's just leave it 8 ohms, in series connection. So this question said we should calculate these two resistance, which is R1 and R2, and they are connected in series. So the first step to take is to draw the circuit. So since it's series connection, you can go like this. Don't mind me, I'm not a good drawer, but just trying my best. Okay, this series connection, and this will be R1 and R2. Remember, in our questions, R1 is 4, then R2 is 8. So the formula for series connection is our resistance is R1 plus R2. This is the formula. So what we just have to do is to impute our 4 on R1, then our 8 on R2. So it's equals to R1 4 plus our R2 8, which is equals to 12 ohms. So this is how to solve series connection. But now let's assume that they can give you resistance up to 3 different resistance. Can give you R1, R2 and R3. They can even give you up to 4. So assuming they give you, this is 2 resistance now, assuming they give you 3 resistance, let's just add N R3, and let us say R3 is 2. So the circuit will be in this form. Okay, this plus and this minus. So this will be R1, R2, R3. R1 is 4, R2 is 8, and R3 is 2. So it's just the same thing. You just have to come here, and R1 is, our resistance is equal to resistance 1 plus resistance 2 plus resistance 3. So is equals to 4 plus 8 plus 2, and guys, which is 14 ohms. These are to solve in series connection. So if they give you up to 5 resistance, you just have to add them together to get your total resistance. Now let's go further to solve for parallel connection. So question number 2, let's say they tell us to calculate resistance in parallel connection. So it will be calculate the following resistance in parallel connection, and it will be resistance 1. Let's take it as, let's still use the same figure, then is 4, resistance 2 is 8. So first thing to do here is to draw your circuit. Anything they are telling you to solve, you first draw your circuit. So circuit, so this is how parallel circuits look like. So this will be R1 and this will be R2. Remember, this is 4 and this is 8. So now the formula to solve your parallel connection, our total resistance is 1 all over R1 plus 1 all over R2. So our R1 is 4 plus our R2, which is 8. The first step, draw your circuit. The second step, get your formula. The third one, impute your resistance 1 and 2 on the formula. And the third one is to find the LCM of 4 and 8. LCM. How many of you know how to find LCM in, we do this in primary school? I hope you have not forget how to do it. So you just draw a quick way to draw your straight line. You put your 4, you put your 8. Now what can divide 4 and can also divide 8? 2 can go. 2 into 4, 2. 2 into 8, 4. What can divide 2 and also divide 4? 2 can go. 2 into 2, 1. 2 into 4, 2. What can divide this? 2 can also divide 2. So 2 into this is just the same. Just put 1 because it cannot go. 2 into this is 1. So our LCM is 2 times 2 times 2, which is equals to 8. So you come order 8. So 8 divided by 4 is 2. 2 times 1 is 2 plus 8 divided by 8 is 1. 1 times 1 is 1. So which is equals to 3 all over 8. So our total resistance is 3 all over 8, but the denomination is bigger, so you have to take it up. So our resistance is equals to 8 all over 3, which is equals to 2.66. If you want to approximate, it will be 2. It will now be equals to 2.7 ohms. So this is how to calculate for your parallel connection. So but let's make it three resistance. Remember when we did for series, we did for 2, we did for 3, and we mentioned that it can be for as much resistance they want to give to you to calculate. So for this one, let's add resistance 3 into it, and let's make resistance 3 to be 2. Let's still use 2. So this circuit is just to add another one to it. This will be resistance 3, which is 2. So to this, you just add plus 1 all over 2. And when you find the LCM, it will still give you 8. It will still give you 8, just like there's 2 here. This is just 1, 1, 1. So it will still give you 8. So it's just 2 going to 8 is 4. 4 times 1 is 4, so plus 4. So it will be 2 plus 1 plus 4, which is 7 all over 8. And when you use your calculator, you're going to get the answer. So this is how to calculate your total resistance in parallel connection. So let's go further to calculate total resistance in series / parallel connection. It's still simple. It's just adding this to this. So first you solve for series, then you now solve for parallel connection, then add the two together to get your answer. For series / parallel connection, to find the total resistance, like I said, it's simple. It's just adding the two circuits together and solve for parallel series, then you multiply them, you add them together to get your answer. So assuming we're given to calculate uh, series and parallel connection, and they give us a resistance 1, resistance 2, and they tell us to calculate series / parallel connection. So first thing we'll do, we'll draw the diagram. The circuit, don't mind my drawing. But the main aim is for you to understand how to calculate your series / parallel connection. So this is resistance 1, and this is resistance 3, resistance 2. This will be 20 ohms, 30 ohms. Then let's give this 38 ohms, then 25 volt. So for this, first, this is parallel circuit combined together with series. So first thing you do, we'll solve for parallel circuit. Remember the formula of parallel circuit? The total resistance is 1 all over R1 plus 1 all over R2. But in this case, we have R2 and R3. So here will be R2 and R3. So just to impute the figure, R2 1 all over 20 plus 1 all over 30. We'll find the LCM. Don't forget 20 and 30. If you do it, the LCM is 60, because it's very long before you start dividing from the smallest to get the ND. But if you calculate it using the previous method I taught you, you're going to get 60. So 60 is the LCM. Now 60, 20 divided 60 is going to give us 3. 3 times 1 is 3, plus 30 divided 60 is 2. 2 times 1 is 2, which is equals to 5 all over 60. So our resistance now, total resistance is 60 all over 5. Remember at the end I told you are going to put the denomination, you take it up and bring the upper figure down to get your total resistance. So 60 divided by 5 is equals to 12 ohms. So we have solved for the parallel connection. This is parallel connection. Remember, they told us to look for parallel and series connection. We should calculate for the parallel and series connection. Now for series connection, now we have calculated for the parallel connection. So now the diagram is going to change. So the diagram will be something like this. Okay. Something like this. This will be R1. Now this will be R2. 12 ohms. 38 ohms. Remember, our formula for series connection is R1 plus R2. So our R2 is 12 and our R1 is 38. So our total resistance is, you can put T to identify its total resistance, is 38 plus 12, which is equals to 50 ohms. You can go further to calculate for your voltage if you were not given voltage, and you can also calculate current, and so on. So another method for calculating your parallel resistance, the short form, which I just want to share with you. If the figure are the same, you just have to divide it by the number. So example, assuming they are telling you to calculate in parallel, let's use parallel, and they tell you resistance 1 is 60 and resistance 2 is 60. Remember, the formula for parallel is 1 all over R1 plus 1 all over R2. So what you just need to do is to, since it's the same number, you just have to divide it by 2. So 60 divided by 2, then it is going to give you 30 ohms. So if it's 30 30, the same thing. If it's 60 60 60, if it's 3, you divide by 3. If it's 4, you divide it by 4. But this is the shorter form to solve it than going to look for LCM, then get the LCM of this, then it's the long process. So the easier way to go about it, if the numbers are the same, you divide it by, if the numbers are the same, assuming they give you resistance 1 2 3 and all the numbers are the same, you divide it by 3. If it's 4 resistance and the numbers are the same, you divide it by 4 resistance. So this is the end of this video. If you are new here, this is Queen Favours TV. If you have not subscribed, please click on the subscribe button, do like and share my video. See you in my next video. Bye guys.